Hey Trigoners, we're going to talk about symmetry today, an idea that you've been talking about for a long time, but we're going to go from something concrete to something a little bit more abstract. So let's start with what we know. So looking at number one, if I asked you guys to show me symmetry about the y-axis, most of you would have no problem, especially after our transformations unit, to take each of these points and reflect them over the y-axis. So 8 end up over here. And that would be a graph that shows me symmetry over the y-axis. If I asked you to show me symmetry over the x-axis, you'd take each point, reflect it over the x-axis. Right, you can do this with me on your paper. And that would show symmetry about the x-axis. Finally, the last one asks for symmetry about the origin. Hopefully you talked about this in geometry last year, but as a reminder, if I were to take this point 2, 7, to reflect over the origin, reminding you guys that 0, 0 right here is the origin, you actually just take the opposite of both of the coordinates. So that would take 2, 7 to negative 2, negative 7. Plot your point. This point over here, 5, 7, would take me to negative 5, negative 7. And finally, 8, 2 would take me to negative 8, negative 2. Oops, negative 2. So that would show me symmetry about the origin. So you can kind of see each of those things happening here. Symmetry over y, symmetry over x, and symmetry over the origin. If you take a closer look at their coordinates, for example, if I were to grab this point here, 5, 7, its reflected point over here would become negative 5, 7. In other words, I've taken the coordinate point x, y, and it's become the opposite of x, y. In other words, if I had a function, which is what we're about to get to, or an equation, if I were to plug in x, or if I were to plug in the opposite of x, in both cases I should get an output that is the same, y, because we can see that those two x values, 5 and negative 5, have the same output values, 7. Alright, if we take a closer look here, for example, if I grab this point, 6, 1, its reflected point is 6, negative 1. In other words, I've gone from x, y to x, the opposite of y. Notice how I say opposite and not negative. Again here, if you have an output of y or an output of the opposite of y, in a function, the input would be the same, x or x. Now I'm getting a little bit abstract here, but we'll take a look at this in an equation in just a second. And finally here, 2, 7 went to negative 2, negative 7. So we've gone from the point xy to the point opposite of x, opposite of y. So let's take what we learned here and let's apply it just to a function. Actually, I shouldn't say function. Let's go ahead and just call this an equation. So right now, this is a function in this case, but let's look at this equation. Y equals the absolute value of x minus 11. So in order to have symmetry about the y-axis, we said that if we input x or the opposite of x, my output is the same. So I'm going to do just that. I'm going to replace x with the opposite of x, and if the result is the same equation that I started with, this graph, this absolute value graph, should have symmetry about the y-axis. Well, you guys know what an absolute value graph looks like, right? It's the shape of a V. And this is an absolute value graph which has been shifted down 11 units. Do you know already whether or not this has symmetry over the y-axis? You do. It does. So let's go ahead. Let's replace x with the opposite of x. When I do that, I get y equals, the absolute value of the opposite of x is also equal to the absolute value of x, or x, which is equal to my original equation. So I'm going to say yes, there is in fact a symmetry over the y-axis. If I'm going to check for symmetry about the x-axis, remember when we looked at our graphs, y went from positive y to the opposite of y. So here I'm going to replace y with the opposite of y. When I do that in my equation, I'd get y, opposite of y, equals, I'm not touching my x's, minus 11. Alright, even if I were to divide out that negative, is this the same as my original equation? No, it's not. I have a negative there and a plus 11, so no, this graph must not have symmetry about the x-axis. And as you know, an absolute value graph shifted down 11 units does not have symmetry about the x-axis. And finally, if I'm going to test symmetry about the origin, I'm going to replace x with the opposite of x and y with the opposite of y. If when I do this, the equation is the same as my original, then my graph must have symmetry about the origin. Well, if you think about an absolute value graph shifted down 11 units, there is no symmetry about the origin. So let's also prove this algebraically. So in for y, I'm going to put in the opposite of y, and in for x, I'm going to put in the opposite of x. So the opposite of y equals the opposite of x minus 11. All right, if I wanted to divide out that negative, I could. Y equals the opposite of the absolute value of x plus 11, which is different than my original equation, so we'll say no, there is not symmetry about the origin. I want you to pause your computer for just a quick second, and I want you to try number 6 alone. Decide, is there symmetry about the y-axis, x-axis, and origin? Pause, and when you unpause, I'll have the answers ready for you. Alright, so I took a quick second just to write out the rules as a reminder to us. So if I'm checking for symmetry about the y-axis, I should replace x with the opposite of x. So I'm going to do that first. Y equals the opposite of x cubed minus 5 times the opposite of x. If the result is the same equation that I started with, then I do have symmetry about the y-axis. Alright, when we take a negative and we cube it, it stays negative, plus 5x. Is this the same equation that I started with? Well, no, everything is opposite, so no, this equation does not have symmetry about the y-axis. Again, this is one that we don't know how to graph, so that might not have been something that we could tell just by looking at the equation, like we could on the first example. Let's go ahead, let's look and see if it has symmetry about the x-axis. So I'm going to go ahead and I'm going to replace y with the opposite of y, x cubed minus 5x. Alright, if you wanted to divide everything by a negative 1, you could. Negative x cubed plus 5x. This is a different equation than we started with. Whoops. So no, we do not have symmetry about the x-axis. Finally, if we want to check for symmetry about the origin, we're going to replace y with the opposite of y and x with the opposite of x. If I go ahead and take a quick second to simplify, the opposite of x cubed plus 5x. To get y alone, divide everything by negative 1. And this actually is the same equation that I started with. So even though there isn't symmetry about just the y-axis, just the x-axis, there is symmetry about the origin. So why am I learning this? Like, what is the point of this? Why do I care if something is symmetrical about the x-axis or y-axis? Well, at this point, we really only know how to graph some of the basics, 6 parent functions, a quadratic, and a line. But if you understand symmetry, you can graph just about anything. So let's take a look here at 7 and 8 and see how our understanding of symmetry can help us graph more complicated equations. So what I want you to do is pause the computer one more time. I want you to decide on 7, is it symmetrical about the x-axis by plugging in the opposite of y? Is it symmetrical about the y-axis by plugging in the opposite of x? And is it symmetrical about the origin? Go ahead, pause. All right, hopefully you decided no, no, and yes. You're going to get to a place where you don't even really have to show work anymore for those. You'll just be able to do them mentally. Maybe you're there, maybe you're not. That's okay. So how do I proceed from here if I don't know what that graph looks like? Well, I'm going to go ahead and just draw a little table. And I'm going to say I'm going to start to plug in some values. At the very least, I know that whatever values I find must also be true if I reflect them over the origin. So let's start with something basic. If I plug in 0, 0 cubed is 0 plus 2 times 0 is 0. 0, 0 must be a point on my graph. I'm going to go ahead, let's plug in the point x value of 1. 1 cubed plus 2 times 1 is 1 plus 3. So I get an output of 4. When I plug in 1, I get an output of 4. Remember, I know I have symmetry about the origin, so 1, 4 would also be negative 1, 4 on my graph. I get to put a second point on my graph. Let's go ahead, let's plug in 2. 2 cubed is 2 cubed plus 2 times 2. So we get 8 plus 4. I get an output of 12. So I have a point on my graph 2 comma 12. I'm a little bit off, that's okay. And I know I have symmetry about the origin, so negative 2, negative 12 must also be a point. This is enough for me to be able to do a sketch of my graph quickly. So let's actually take a quick second. Just like on the last problem, I'm going to write here x-axis, y-axis, and origin. I want you to pause the computer and I want you to do the test for symmetry. Decide is it symmetrical about x, y, and the origin. Unpause the computer and check your answers with me. Alright, if you tested these, you should have gotten yes, it is symmetrical about x, no, not y, and no, not the origin. Make sure you've actually tried those on your own so you get a little bit of practice and you don't come in confused the next day. If you're not getting them right and you're not sure why, just bring those questions in for us. So the next thing I have to decide is what the heck does this graph look like? So I'm going to go ahead, just like before, I'm going to make myself a little bit of a table here. And maybe I'll start just like the last problem by plugging in 0 for x. If I do that, I would get 0 cubed minus 4y squared equals 1. 0 cubed is 0, so 4y squared equals 1. Y squared equals negative 1/4. And even though we got really comfortable in the last chapter with square rooting negatives, we're back into the real number system because we're creating graphs. So we're going to go ahead and say there's no solution there. When I plug in 0 for x, there is no solution for y. All right, let's go ahead. Let's go plug in 1. All right, if I plug in 1, 1 cubed minus 4y squared equals 1. All right, subtract 1 from both sides, we get 0. Divide both sides by negative 4, so y squared equals 0 and y equals 0. So I have a second, I guess a first point on my graph. So I'm going to go ahead and I'm going to plot 1, 0. Let's go ahead, let's plug in 2. You might want to have your calculators handy because the numbers are going to get a little weirder here. So we plug in 2 cubed minus 4y squared equals 1. So I get 8 minus 4y squared equals 1. Subtract 8 from both sides. So I get negative 7. Y squared equals 7 over 4. Square root both sides. And I get y equals, punch that into your calculator. When I did that one, I get about plus or minus 1.32. So 2 comma plus or minus 1.32. Now actually in solving that, let's go ahead, let's plot those points. So 2 comma 1.32 takes me about here. Whoops, I'm going to get that pen working, 1.32. And 2 comma negative 1.32 takes me about here. It actually caught the reflection over the x-axis for me simply by solving, which is just affirmation that your work over here was correct. Let's go ahead, let's plug in one more number. I can't really tell the shape of my graph right now with those 3 points. So I'm going to plug in 3. 3 cubed is 3 cubed is 27 minus 4y squared equals 1. So I get 27 minus 4y squared equal to 1. Negative 4y squared equals negative 26. Y squared equals, divide both sides by 4, 13 over 2. Go ahead, square root both sides. Punch that in. When I punched that in my calculator, square root of 13 over 2, I got about plus or minus 2.55. Let's throw that on the graph. 3 comma 2.55 and 3 comma negative 2.55. All right, it looks like I'm getting a graph that looks like this, and we can see that symmetry about the x-axis. I'm going through everything a little bit quick right now, but I think this is just a concept where it's good to get some exposure to it and then to try some out on your own. You're going to see here when we get into some of these absolute value problems, they get a little trickier. So I actually don't want you to graph these. Do not graph these tonight. But just for your own practice, I want you guys to decide, is there symmetry about the x-axis, y-axis, and origin on 9 and 10? And then we're going to check those with each other when we come in tomorrow. All right, be prepared to have some homework time in class tomorrow, which we don't get often. And then maybe a free night of homework tomorrow. Maybe no homework tomorrow night. That'd be kind of nice. So bring in your questions, okay? I will see you tomorrow.